Hey, Michael, you can go ahead and ask me any questions you might have while we're waiting. We only got about a minute before people are supposed to be here, but you might be the only one that shows up because this is completely optional.
Good afternoon, Professor.
How you doing, Marcus? Or Michael, sorry.
I'm doing good. So I wasn't here for the last Zoom, and I was just wondering, like the stuff that you went over. I had to attend a
Gotcha.
graduation
So
for my
last night,
sister.
or you mean like a previous one before that?
Uh, yeah,
Yeah,
yesterday
last
night.
night.
Yeah.
Okay. I did already post that, so it is available. And in fact, I posted it last night. So it's up there. But what I ended up doing was I ended up doing a lot of the examples at the end of chapter four. Sort of what I've been doing in the last 2 days is talking about chapters four and five, but pretty much I've been strictly sticking in four. But that allows me also to do five really quickly. So that's all we did was just a bunch of examples for chapter four, specifically talking about applying Newton's second law to like a chain of boxes. So if you had a box and then a rope attached to that box to another box and then a rope attached to that box and you pull on that front rope with a certain number of newtons, what's the acceleration of the whole thing and then what's the tension in the ropes? I did that kind of problem. I did an Atwood machine, which is basically just a pulley with a heavy mass on one side and a light mass on the other. You're assuming the rope is massless and assuming the pulley's massless. I solved that problem for both the acceleration of the blocks as well as the tension in the rope. Uh, I did some normal force examples so you guys would see how normal force can be affected by uh, basically by things like an accelerating reference frame. For instance, I examined a person riding in an elevator standing on a scale, and if the elevator accelerated downward, what would the scale read? So I did that kind of problem. But that was basically it, and I talked a little bit about up and coming things like I might be considering. I'm almost certainly considering giving you guys another chance at your first face-to-face test, and I just haven't decided all the details on it yet. But there's a good chance that if you want to, you have the option of doing something else to improve your test one score. So that's about all you missed, though.
Okay. And regarding the second face-to-face test,
hmm
what chapters will that be on?
I really don't know until literally maybe at best a week before the test date because what I try to do is get as many chapters done up to that point and test all the way to the end of a chapter, unlike the last one where I went up to the middle of a chapter. I prefer not to do that. So it all depends. If I get enough chapters done, then I might actually, instead of having a half of a chapter at the end, I'll just do it one less chapter or one half less of a chapter. But what they normally entail would be probably chapters six up through six, maybe. And it's, mostly on the ones since chapter three, but including the second half of chapter three. But there will still be questions from chapters one, two, and three as well.
Okay.
Okay. But yeah, I really don't know. Hopefully, I will be well into chapter six or completely finished by chapter six by that second test. But we'll see. Any other questions, sir? This is also a question and answer session in terms of solving physics problems or asking things about the syllabus or any past tests or anything like that. So
Nope.
what it,
That's all I have for you.
that's cool. Well, stick around if you want in case anybody else has any other questions. Jacob or Angelina, do y'all have any questions?
I had a quick
Yeah.
question. Oh, sorry.
Okay. Go. I'll do ladies first. Go ahead, Angelina.
I had a quick question
It's
about the
always sexism.
face-to-face test.
Uh-huh.
That's okay. I think it was set to close yesterday and not today.
Yes. For you're
The
talking, are
first
you
week.
in the 240? You're in the 241. Are you N02 or are you O01B?
O01B.
Okay. Uh, and you were trying to take it what today?
Today,
Okay.
yes.
Let me go ahead and make sure. I think I'd already said it, but if I didn't, then I'll obviously correct it for you. Let's go back. I'm looking right now, going to the modules, and I think I remember typing your name as one of the special ones that gets extended period because yeah, obviously we had some problems associated with it. I'm going up to
Yeah.
the face-to-face test, and do you have a proctor or will you be doing it at home or on your
Um,
own, I should say?
yeah, I'm using the lockdown
Webcam.
browser.
Okay. The way it works is if you have a Proctor, you can go with just the lockdown browser. That's why that one has a password. But if you don't have a Proctor, you have to go with the lockdown browser plus the webcam. And in fact, you're supposed to be if the webcam is attached to your monitor, you really need a mirror as well. But I can give you more time if that's a problem for you.
I have a mirror with me.
You do? Okay, so let me explain what that's going to be. And
Okay.
yes, it does look like that canceled out tomorrow, so I'm going to go ahead and change that for you. Or,
Thank you.
excuse me, I said cancel out tomorrow. Tomorrow and yesterday are two entirely different days, but for some reason I just put one instead of the other.
It's
I'm going to
okay.
move it to the 12th. That'll give you, in case you don't get it done today. Actually, let's go ahead and give you to the 13th.
Thank you.
Okay, and that goes for I've got like five people in that group that missed it, so they're all welcome to that. Let me explain to you for the video's sake as well. Well, what I want to be done with regards to an online test that you proctor yourself is the ideal scenario is you just have a webcam that's not fixed to your monitor, and then you'd put the webcam over here or over here while you're working on the test so that I can see your hands, which are going to be on the desktop with your keyboard. I can see it, and with a little bit of the monitor at least, I can see. So that's what the webcam is trying to catch, and it should catch from above your head all the way down to below the desktop, so that and then you never put your hands below the desktop because that could be considered, potentially cheating. You can't wear you can't wear earbuds, but if you want to play music, you can play it lightly as long as I can hear stuff. Like if people were talking in there, I want to be able to hear that. But you're welcome to play music out loud. Uh, you have to use the camera to show the area that you're studying or that you'll be taking your test in. You have to show all the doors in the room and show me that they're closed. And if any of them opens, ideally the camera needs to be on that so I can see everything that happens if someone comes in. And if any of
Okay.
that kind of stuff breaks up, I might make you, say that one's not going to count. That being said, none of that ever happens. Okay.
Mhm.
But if you don't have that separate webcam, then all you have to do is adjust your monitor so that it's sort of, instead of the front of the monitor being parallel to the desk and parallel to your shoulders, you tilt it just a little bit so that I can look through the camera at the mirror and then see your hands and face. So sometimes
Okay.
that takes at least like an 8x8 mirror, but you can use a full body mirror if you have one of those, and you just lay it somewhere to the side. And then my idea is, like I said, I should be able to look through your camera through the mirror and then see your desktop and your head, and basically your hands would stay visible the whole time.
Okay, thank you.
No problem. Oh yeah, one other thing too. When you're doing that, if you have any blank paper, and it says this in the process, but if you have any blank paper, you have to put it one by one up to the camera slowly, so that I can see every part to make sure nothing's written on it, and then the backside too, for however many sheets you have. And of course, you're not allowed to use your phone. Your phone should not be within lungeable distance. But other than that, it should go fine.
Okay, thank you. And I can use the formula sheet.
Yes, yes, and the formula sheet is at the bottom of the test. But if you have a hard copy, you can use that, and that would just be one of the things that you show me. You're not supposed to alter it, but the things that I do allow you to alter is
Mhm.
in the individual equations. Like there might be a symbol for v, and you could write v means velocity, and a means acceleration. You can't do stuff like writing the names of actual equations or this is Newton's law of gravity. You can't do that kind of stuff because sometimes I give little what I think is supposed to be easy questions, and I'll ask you state Newton's second law. So if you had that written on your equation sheet, that wouldn't be very helpful.
Okay, thank you.
No problem. Good luck, Angelina.
Thank you.
How about you, Jacob? Sorry, but I will always defer to let ladies go first.
No, you're fine. I had a question about the extra credit three. Was that the? Oh, let me pull up which one that
Okay.
is.
Are you in
Uh,
N02 or are you in O01B?
O01B.
Okay,
It's relative velocity.
gotcha. So
Yep,
was
I
this in
think.
week two, or I'm looking for
Um,
yeah, the relative velocity one?
yep, I think I sent you an email about that asking how exactly, like what we're supposed to be solving for, because the
Gotcha.
example that's listed there has a couple of parameters. Like this one is this ratio, the speed of light, and this other one's this ratio, the speed of light. But the one we're given, we don't have any of
Yeah.
that or what we're supposed to solve for.
So when you're and I'll pull up the problem real quick. Let me go ahead and do that. I'll pull it up and share the page with you guys. Let's do share screen, advance, and you actually that's referring to a video that has a date on it, so you can actually go to my YouTube channel. Oops, I went to the wrong place. You can go to my YouTube channel and do a search for that date in the form of two-digit month, two-digit day, four-digit year, and that should actually bring up the very lecture that that was in. So hopefully that'll help you a little bit. All right, here's the question. So what it says in lecture on 129.25, face to face was on 128.25, but that one won't be on the internet. I covered the relative velocity formula, VAD equals VAB plus VBD. I did this in your class too. It was, I want to say in chapter one, maybe towards the end of chapter one, but I didn't do these other examples. Uh, what you have is C, as you see right there, is 299,792,458. But to be honest with you, when you're given speeds like 3/4C, 7/8C, or C, the C's always cancel out, so you never actually have to put them in here. And what you're supposed to find here is in this problem, you're asked to rework the problem using Einstein's relativistic addition of velocities equation and to find the correct answers. Tell me what you think about the relativistic, non-relativistic, and compare to one another in each part of the question we worked. Take a photo of your neatly completed problem, convert it to a PDF. So that's what you're supposed to do. This is the equation. So this is the way this is supposed to be read is VAB means the velocity of A as seen by frame B, and VBD means the velocity of B, as in boy, as seen by the frame D, as in dog. Now, the big thing is the frame might actually be a reference frame that I'm talking about, like Earth, but it could also be ship B or ship C or something like that. So, with that in mind, let me now go ahead and stop sharing here. But I'm going to go to my YouTube channel and find that particular video. It was 129.25. So I'm going to do a search for my on my YouTube channel for that particular video. I'm going to go ahead and share the screen. Uh-oh, went to the wrong place. Actually, I just ended up in regular uh, YouTube. Okay, I'll do it this way. All right, now I'm going to share screen again. Hmm, dot, dot, dot. There it is. So this is my YouTube channel, and remember that question said 129. So I'm going to type in 01292025. That's part of that code that you'll look when you look at my videos. You'll see a little code in the box right below the title. I'll show you one in a second, and that's what that code is. So notice this says right here. I'm going to click on it. Right here's the code. See the physics 241 N02B 01292025. That is the day that I'm referring to. If memory serves me, this calculation was done at the very end. But even if it doesn't, I can stop and click and look and see. Yep, that's not it. Keep going. Yep, that's not it. Keep going. And like I said, memory serves me. It should be at the very end. Ah, here it is. So this is the problem that we're actually supposed to be working. And the rule that I was teaching you guys, and this is important because it is part of Physics 241, and then it continues to be part of Physics 242. A relativistic addition of velocities formula is just slightly different from the regular addition of velocities formula. And the way the regular addition of velocities formula works is if you write a velocity in the format that I've taught you, like this VAC that you're seeing right there, you can see that, can't you, Jacob? Is that big enough?
Yeah,
Okay.
yeah, I can see it.
So that means the velocity of A, which refers to the ship, as seen by C, which is probably going to refer to this ship C. Okay. If I want to know that, all I have to do is write a formula, and the first subscript of the first one has to match the first subscript there, and the last subscript of the last term has to match the last subscript. So see, the AC is AC, and then all that matters is the middle two are the same. So if you had an A here and a C here, no matter what you put here and here, as long as it's the same thing, it would be a valid equation. Now, what you'll find is occasionally when you go to do that, you won't have a velocity of B with respect to C, but you might have a velocity of C with respect to B. That is why I gave you this additional rule that says the velocity of A as seen by B is equal to the negative of the velocity of B as seen by A. So that's sort of the big trick on using this. Now I'm going to go a little bit further forward. There you go. I think this is enough where you can see the problem. So this is the problem. We have a spaceship A, and notice both reference frames, are all reference frames, I should say. All reference frames have to agree on which direction is the positive direction. So you can sort of imagine them all saying to the right is positive and up is positive, and then they all got to agree on that. So spaceship A is moving to the right at 3/4 of the speed of light. So I said the velocity of A as seen by Earth is positive 3/4 c. That means if the people on Earth are trying to measure the velocity of this ship, they would say it's moving at 3/4 of the speed of light. Additionally, there's a spaceship B that's moving to the left, and as seen from Earth, obviously its velocity has to be negative 7/8 because it's going to the left. The negative has to be there, but in this case, it's 7/8 the speed of light, which is obviously a little bit faster than 3/4, because if you multiplied 4 and 3 by 2, you get 6/8, and you see this is 7/8. So if in this problem, now that I had those numbers worked out, I can see exactly what's asked of me. And I'm going to pull it just a little further forward. There it is. What is the, there you go. So what is the velocity of B as seen by A? So what we do there is we write down the velocity of B as seen by A is equal to the velocity. This part right here has to be B, and this part right here has to be A. Notice I have a AE and a BE, so E is the most likely one to use. And with that in mind, actually, let me, oh man, I don't have my iPad with me. Uh, Anyways, with that in mind, what you would do is just immediately put these results in. So actually, hold on just a second. I can get my iPad. That's right here. So I'll show you exactly how this is done. Now the video shows it too, and you can see we're at the 1 minute 20 second mark. So if you just fast forward to the 1 minute, or excuse me, 1 hour 20 minute mark and 35 seconds, that's where it is. Oh man, I was talking without that. Did y'all hear what I was just saying about the 1 hour 20 minutes and 35 seconds?
Yep.
Okay, cool. All right, so I've got my iPad on now. And what I'm going to do is open up a new document, if it ever allows me to. And I'm going to draw this problem and show that I see positive 3/4 and I see negative 7/8. I think that's good. I'm going to go ahead and stop share. I'm going to say OK to this message that someone's sending me. Now I'm going to do share, advanced, iPad, share, iPad. And now hopefully I can just pull this up. Okay, I'm making a duplicate of that file so I won't have to make it again. Hopefully this will work in a second. There it is.
Traditional vector addition. We use the relativistic addition.
Yes, and I'm going to show you both right now. So what we have is the Earth down here. We've got a spacecraft A right here that's moving at the velocity of A as seen by E is positive 3/4 c. And then we have a spacecraft here, which is B, and the velocity of B as seen by the Earth. And this is all one-dimensional motion, so I could technically put vectors over it just by writing it with pluses and minuses because it's one-dimensional and that's acceptable. I'm just choosing not to because it's a pain in the butt to write that. So this one's negative 7/8 c, and what we want to know is the velocity of double check the velocity of B as seen by A. That's part A. There's another part too, and I'm going to address that. Now, the rule is, remember, in this case, we want the velocity of B as seen by A. So the rule for making this addition formula is the first subscript has to be the first subscript of the thing on the left. So I'll put a B there. And I'm just going to put an underline there to remind us that we have to have a second subscript. Now I'm going to put a plus. Now I'll put another V, and I'm going to put a little underline there to remind us that we need a first subscript, but the second subscript has to be the A. So hopefully you see that pattern, or that pattern makes some sense to you. That has to be this, and this has to be that. But the only thing that really matters with regards to the other symbols is these two have to match. So what we have is a VAE and a VBE. So it seems reasonable that we'd want to put an E here. So that's what I'm going to do. I'll put an E here. And that's technically the right formula. The problem is we have VBE, but we don't have VEA. We have VAE. But like I said, that other rule is that the velocity of A as seen by B is equal to the negative of the velocity of B as seen by A. Uh, that's basically like a statement of if you're sitting in a car, like in the fast lane, and imagine sitting in a car and you're actually turned sideways while the driver's driving, so we make it safe, blah, 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 right? You're riding down the road like this, and you're in the fast lane, so maybe you're going 65, and then someone else is in the slow lane and they're going 60. So to you, you would say that that car is going to your right, and you would probably call that right the positive direction. Now, once you've chosen the x direction being positive to your right, then the other car has to use a coordinate system in which their x direction is also pointing to your right. So the other car, what it sees is if it had a driver, I mean, a person sitting in the passenger side looking this way, it would see your car going to the right. Their right, though, which is our left. So you would call that, since they knew their left is the positive direction, they would call that velocity negative. And in fact, it would be 5 miles per hour in the positive direction for the first person and negative 5 miles per hour for the second person. Does that make sense?
Yes.
Okay, so that's why that VAB is equal to the negative VBA. That also allows us to go ahead and change this and have a VBE. That's going to be negative. Well, let me not write that yet. That's going to be VBE. But now what I'm going to do is replace VEA, with VAE, but a negative of it. So that's all I got to do. Now I can plug in the numbers. BE is negative 7/8, and then minus VAE is 3/4 C. And you see what happens. These both had C on it, by the way. And you see what happens. This becomes 6/8 C. So negative 7/8 minus 6/8 would actually give us negative 13/8 C, which is clearly greater than the speed of light. Does that make sense?
Mhm.
And that's what you'd expect in everyday life. Like the example I used in class is a person throwing a fastball on a flatbed trailer. If the if the flatbed trailer is being pulled behind a truck going 60 miles per hour and you throw a ball at 50 miles per hour in the same direction, then someone up in front of the truck looking just at the ball would say that ball's coming at them at 60 plus 50 or 110 miles per hour. That's what's happening here because one car is moving or one aircraft is moving at 3/4 C towards the other that's moving at 7/8 C towards it, then those two velocities add. Sort of like two cars coming at each other at 35 miles per hour is equivalent to one car being locked perfectly still and the other car ramming it at 70. Does that make sense?
Mhm.
Okay, so now let me show you the relativistic version, and this is pretty neat. The velocity of B as seen by A relativistically is the exact same formula. I would start off with the plus like I did before, but there's no need to, so I'm going to go ahead and, well, actually, there is a need to. I'll go ahead and write it VBE plus VEA. Now, the only difference between relativity and classical physics is down here at the bottom, there's going to be a plus, the same two quantities. So VBE, VEA, and then this is over C squared. Now we realize we don't have an EA, so I'm going to use that same rule, but with the negative. So this is going to become VBE minus VAE. And then down here, it's going to become 1 minus, because VEA has been replaced with VAE negative. So this will be VBE VEAE over C squared. Now I can take this into account. This would be, what was it, 3? No, VE was negative 7/8, wasn't it? So this would be negative 7/8 C minus 3/4 C. That's the numerator. And then I'm going to have 1 minus. Now I have a negative 7/8 C for that first factor, and that other factor is technically just positive because I put this negative here in place of where it was an addition formula. So I've already taken care of that. So I just write 3/4 C in here, and you see that the C squared in the bottom cancels out with these two C's. Now this math is really amazing, but check it out. We're going to get negative 13/8 C in the numerator, and then in the denominator, because I've got those two negatives, it's ultimately going to be a plus, but I end up getting, if we canceled anything out, it would be nice, but nothing cancels out here. But when we multiply 7/8 times 3/4, we get 21 over 32. So this is going to be plus 21 divided by 32. Now, this number is 32 over 32. So in the top, you still have negative 13/8 times the speed of light. But in the bottom, we have 32 plus 21. That's 53 over 32. Carrying on, I get negative 17/8 C. Now, dividing by a fraction is the same thing as multiplying by the reciprocal, so that's 32 over 53. Now you can see this is 8 times 4, and 53 is what? 4 times 17? No, that would be 40. That would be, no, that's too much. How about 3? 3
Where did you
times.
get 17/8?
Oh, I obviously got it from drinking. In other words, I screwed up. No, it was supposed to be 13. Thank you for catching that. That's nice. I don't know where the 17 came from. It's just something my brain made up. But the good news is you caught me, so that's good. This 8's going to cancel out with that 8. I'm not seeing 3 times 13, 4 times 13 be 40
It should be
plus,
52.
is that 52? Gotcha.
Hmm. And
Oh,
then I
yeah,
think I've
1 and
solved
3. Yep.
all the way down to the second one with VPA. Yeah, I misinterpreted the whole the whole thing from the beginning. I was trying to figure out some way to just rearrange the relativistic equation.
Gotcha.
I was lost on how to like actually on
Yeah,
what
this
to do.
is yeah, so this is all you have to do. And then of course 4 times 13 is 40, 52. So this would be 4 times 13. That 13 is going to cancel out with this 13, and ultimately therefore the answer will be negative. All we have left is 4 times, that can't be right. You sure that was 53? Or
I
did
think
I
it was
get
52. It ended up being
21?
52 over 53,
Yeah,
negative 53.
32 plus 21, 53. Yeah, I think it's still 53, not 32, because right now that's giving a value of negative c, and that can't be right. So yeah, I think it was 53, and that does look like the math is right because we're adding 30 and 20, that gives me 50, and 2 and 1, that gives me 3, so it's got to be 53. And that also makes it where I can't cancel this thing out. So I'm going to get rid of that. But what we do have is a little cancellation from the eights canceling. So I get 4 times 13 is going to be 40, 52 over 53C. I think maybe you're remembering the 52 from what the right answer is. I don't know, but this is supposed to be
Oh, no,
50.
I got that answer.
Did you? Okay. But see how close that comes to being C? It's crazy, like
Hmm.
7/8 and 3/4. That's way bigger than C. But somehow this equation always has a way of finding it. It just be barely less than 1C. And the other cool part is part B. I think they ask you for the velocity of a photon. In other words, you can imagine the spaceship firing a photon torpedo, and the photon has a velocity v photon with respect to b is equal to negative c, and then I ask you for the velocity of the photon with respect to a, and it's the craziest thing, but you're going to get exactly negative c.
I did get that. I thought that was kind of really cool how it worked out like that.
Yep, that's it. So that's what you're shooting for there. And I don't mind. You can watch this video. I should be posting it. You can watch this video and copy it verbatim if you wanted to. But I think the big thing is, especially since you've already worked it to some extent, you've learned the material from just doing it. So if you can close your book and do it, you get full credit for doing it, whether I showed you first or you figured it out first. Does that make sense?
Yeah, yeah, it does. Thank you very much.
No problem. Anybody else have any other questions?
Yeah, thank you for working with me with getting the test all set up on Monday. I am sorry about that hassle. That was
Don't worry about it, man. It's really, there's a lot of things going on, and the summer makes it harder, and there's all sorts of things that I can screw up on my side. So, but yeah, I appreciate you saying that, but don't worry about it at all. Like I said, you guys are students, and I was a student once. I get it.
mm. and
Thank
then and
you.
then for the
You're welcome,
mirror,
engineer.
I
Hmm.
used a second computer on full screen camera, so it was
Okay,
just the camera, and that's fully visible the whole time. So you
that
should
should
be
be
able to
fine. Yeah,
see my whole setup,
excellent
and then
idea.
the pan arounds beforehand.
Great,
Yeah,
that's
all right.
cool. I thought I sent an email explaining all that about the mirror and stuff, but I can't find that email for anything. Did I send you guys an email like that?
I'm pretty sure I remember seeing something like that. Let me see if I can
Yeah,
find
I
it.
was looking for it last night and I couldn't find it anywhere. I was like, man, did I write that and not send it, or did I
Um,
just?
okay, it was sent on June 4th at 9:54 a.m.
Okay,
and it looked like it's a reply to the
okay,
second one you sent on June 4th or to the first one.
gotcha. Thank you. That's probably why I didn't find it. I would have not even recognized if it's a reply to something else. So that's probably why I didn't see it. Cool. Thank you for that, Jacob.
Hmm.
Anybody have any other questions or problems they want to see how they're worked or anything like that?
I just wanted to double check that the due date was changed because it still says June 10th, I think, for
Okay,
the
let's
face-to-face test.
double check that again. And remember, you're doing the one with the webcam, right?
That's right.
Okay. So I'm going to look at that again real quick. And I might have actually done it. Oh, you know what I did? I see it right here. I changed it, but I didn't push save. So that would do that just about every time.
Okay.
All right, so let me try to change it one more time. Ah, I see. It wasn't quite as bad as I thought. Did I say I moved it to the 12th
uh,
or 13th?
13th?
Yeah,
That's
that's
right.
it. That's Friday. So I think that's good. And I see why I had changed. Actually, I hadn't hit. It wasn't that I didn't hit save. It was that I did it in one box, but not the other.
Um,
So now it's taken care of.
okay, I see it
You
now.
see it?
Thank
Okay.
you.
Cool. Thank you for that. Sometimes, by the way, when that happens, you sometimes have to back out of that page, empty your cache,
Mhm.
and jump back in. But luckily, it didn't do that this time.
Okay. Thank you.
You're welcome. Anybody have any other problems that are bothering you from chapters one, two, or three, or anything, or for any of the subsequent chapters for that matter?
I think I'm good.
Okay. Well, that's
I think I'm
cool.
also set up.
All right, thanks, Jacob. I appreciate you guys coming. Does this time work a little bit? Well, you guys are from the O01B. Y'all don't normally get to come to the last night class, do you?
No, but I watch the YouTube
No.
sometimes.
Oh, you do? Okay.
Hmm.
Does this time happen to work for you? Because I did send emails out, and I think Angelina replied to me on one of them,
Hmm.
but I only had like three students reply. This could be something that I could start doing every Tuesday, Thursday. It wouldn't be a problem just to make up for not being able to meet with you guys on the day that I chose, because I found out that I've got like 4 or 5 students in a face-to-face class at the time that I
Hmm.
offer my online class.
Oh shoot.
So yeah, it's like I chose the one worst time where I got 4 of my students out of 24 not able to come.
Dang. This time works for me.
Gotcha. I
I
might
think
do
this
that.
time works perfectly. I just get out of the lab at this time.
Cool. It'll be at least a question and answer session. Maybe it'll be just Tuesdays, maybe it'll be just Thursdays, or maybe it'll be both. I don't know, but I'll make a decision on that. And like I said, the fact that I got 3 people helps me. If I would have gotten even more, that would have been better. But I don't think this is too bad, and it doesn't interfere too much with my normal schedule, so I think I can fit that in.
I appreciate you setting this up.
No problem. You're welcome. Well, I'll go ahead and let you guys go. Remember, if just in case, like I've said this over and over on the video, but I know not everybody's actually even watching the videos, it seems. So just to let you know now that I've got you here, uh, if you have a problem with any physics problem, especially the ones like on the practice tests that are multiple choice, take a screenshot that includes the full question and the possible answer choices and just I
Mhm.
mean, text it to me. Texting is the quickest and most reliable way to get up with me. Uh, I'm gonna eventually find probably, but there's some kind of handshaking problem going on between my various editions of Microsoft Office, or whatever
Um,
the email suite is, Outlook. That's the word. So I have my desktop, I have a laptop, I have a couple phones, and then I have my computer desktop at work. And between all those, I think some of them are pulling the mail off the server after they check it, and then that
mhm.
leaves some of the other applications not seeing the mail. And that's all I can figure is why I'm missing emails. But I do consistently miss emails, even though every morning and every night I go through all the emails that I've received since the previous day, and still I miss them. But if you do miss me, like if you send me an email and I don't respond within one business day, go ahead and send me a text, and that should get your response real quickly.
Thank you so much.
You're welcome. Have a good one. Let me know if I can do anything else for you guys.
Thank you.
All right.
Thank
Have a
you.
good
Have a good
evening.
night.
You too. Bye bye. All right. That's about it. Bye bye, everybody. Thanks for coming.